Momentum. Number 4. Conservation of linear momentum, continued collisions. It's not doing this again. Okay, types of collisions that we can have: rebound or coupled and sticking together. So rebound is when something hits something and the other one moves on. Coupled is when they might stick together. For example, train carriages might stick together. So we're going to go through a couple of those examples and have a look at them. So rebound, when objects bounce off each other. Here's an example. Here's M1 with initial velocity moving this way. M2 has no initial velocity. M1 collides with M2. M1 keeps moving on but with an unknown velocity. M2 now has a velocity, so now has a momentum. Here it didn't have any momentum. And so we need to recognize that the law of conservation of momentum is still applied. Over here, let's pick a nice color, green. Okay, the initial momentum is momentum of 1 plus the momentum of, the initial momentum is the momentum of 1 plus the momentum of 2. In this case 2 is 0, so but we do have an initial momentum, and here the final momentum is the momentum of 1 plus the momentum of 2. And so this is conserved. We're not losing any mass, and everything obeys the law of conservation of momentum. And again, a before and after diagram helps. The initial momentum must equal the final momentum. Yep. And this is how we do it. Notice the nomenclature, or the way they write it, is they use subscripts to denote the different masses or the different bodies, and they use U in the initial momentums and V in the final momentums. That's a good habit to get into. Let's do an example. We have a cart, 2 kilograms, traveling at 6 meters per second, collides with another cart, 0.4 kilograms, traveling in the same direction at 2 meters per second. It bounces off as shown. Okay, there's our initial. So both of them will have some momentum. And then our after is the 2 kilogram one proceeds at 3 meters per second. So it's actually slowed down, hasn't it? And so it's lost some momentum. That momentum must now be on this cart, but we don't know this velocity, and that's the question that we're asked. What is the velocity here? So we have an initial momentum must equal a final momentum. And notice that here they've said that this is the initial momentum. Now they could have put in a couple more lines of working here. I would have liked to have seen P initial equals P final, and that just tells us that the initial momentum equals the final momentum. And here they work it out, and they could have done another line of working there. They could have expanded this a little bit more, just to make sure it's clear. Notice that these velocities are positive, even though it's not written. There's a little invisible positive sign there. Maybe I should pick a different color. And there's a positive sign there, and when they work this out, this is positive, so this one continues moving at 17 meters per second. So it actually speeds up, and that's to be expected. This little object's being hit by this big object. Makes sense? Of course, it's physics. So there we go. This is just drawing the arrows in. And what about the other type of collisions that we're talking about, the coupled and sticking together, where they get stuck together? Law of conservation of momentum still applies. Shouldn't be a surprise. And the mass of the combined body must equal the masses of the individual bodies that collide. So we can't lose any mass. It's a closed system. For example, arrows sticking in a target, or 2 cars colliding. Now we'll be doing a prac that demonstrates all this in the lesson, but we'll keep going. So let's do an example. Shopping trolley loaded with shopping has a mass of 60 kilograms, rolls across the floor at 4 meters per second, collides with an empty trolley, 25 kilograms, which is stationary. They lock together and roll on as one. Calculate the velocity of the 2 trolleys when locked together. So let's draw a diagram, shall we? Okay, so let's draw a shopping trolley. There's one shopping trolley. This one's full of groceries. There's our dodgy second shopping trolley, which is empty. This one weighs 60 kilograms, so we also label everything. It's traveling at 4 meters per second to the -1 in this direction. This one weighs 25 kilograms. Okay, and it's 0 meters per second. So it has no momentum. There's our before, afterwards. Whoops, what's the hell's that? Let's just get rid of that line. I got carried away there. There's a trolley full of stuff. Okay, and it's locked together with the other trolley. Okay, and they're all moving, so now we have a mass of 85 kilograms and we don't know its velocity. So, but we do know that the P initial must equal the P final. So if we can work out the initial momentum here, we should be able to work out the momentum, final momentum here, and of course we know the mass, we should be able to work out the velocity. Alright, let's see how they do it. Let's get rid of all this drawing, and they put the numbers in. Okay, noticing that again they are putting a little invisible plus sign there, and because this comes out as plus, it's moving on in the same direction. Now notice that this was moving at 4 meters per second, then when it locks together and becomes heavier, it actually slows down, and that makes sense too. Conservation of momentum. Let's clean all this up and move on. So you should now be able to do questions 9, 10 and 11, and on the OneNote you'll also find a whole lot of an episode of Mythbusters relating to a car crash. These are the times to actually watch in each clip, because some of it, I think it's got ads in it or something. Okay, so you should watch that. Whilst you're watching it again, you're not watching it just for fun. It is fun to watch, but you're also trying to look out and use the physics, listen, see if there's any physics being talked about, and see if they actually get it right. Now you're also able to do questions 24 through to 27 and 29 and 30 in OneNote, and there'll also be a sheet called Momentum, Force and Impulse questions, and I'll also put a link to a video that will reinforce all this stuff, and that will be on your OneNote. So that should pretty much just do us, I think. So cheerio.